Miller uses something called a fiber washer. And as a matter of fact, they use a fiber washer both on the inside of the spool, this being the spool, and a smaller one on the outside of the spool. This particular welder, which is an airco, doesn't use a fiber washer at all. Instead, it uses this black washer, which is apparently the same exact plastic as the spool itself is made out of. There's where apparently they put this thing together wrong too, one of the previous owners, because they got this spring mark where the spring has been riding in there. Lots of goofball things going on with this welder I have to straighten out, okay? But anyway, according to the parts blow up, this thing is supposed to ride directly on that, and then because of the thickness of this thing, it would clear the metal by roughly 1/8 of an inch, possibly a hair more, but not 3/16. But in any event, this thing's supposed to ride in the center, not move around. So I imagine originally it was bonded somehow, but I don't know how. So I was going to tap these things out, 632, and put it back together. So in order to hold this dealie together, this is a real simple drive roll setup. This goes against the metal plate and is attached to the metal plate. These two things go over the stud, like yay. I can do it in the real world, like this sort of. This goes like yay. That goes like that. This goes like this. This thing drops, wait a minute. This thing drops down onto that. Okay? And then this screw goes in about 2 turns, believe it or not, to where it becomes generally tight enough to put a little bit of brake drag on the spool. Okay, so that means it's like yay. This is without the spool, of course. The spool hub, rather. But there's no fiber washer at this end, either in my welder or in the parts drawing. And as a matter of fact, there is no fiber washer at all, period, in the parts drawing. And this washer is shown, and these 3 are shown, and this bolt, which I call I guess it's a machine screw or whatever you call it. It's about 5/16. But whatever it is, it's the correct one. And it's the correct length, believe it or not. According to the parts blow up anyway, the dimensions in the parts blow up. So, the big question is, am I going to remake this damn plate? And if I do, that's going to be a big hassle. Because I have access to a machine shop, but it's somewhat costly and kind of a headache to get to it. For reasons I can't go into here. But you can tell, well, maybe you can't see down the hub of the hole. You probably can't because it's not illuminated with a bore scope or anything. But I cleaned it out. Now it's cleaner. But the deal is, you center drill that and tap it out, I guess 5/16, 18, whatever the pitch is. And then remake this thing. And I was going to use probably a Morse taper reamer in the plate. And tap the back of this maybe a 1/4 National Course, and make the small end of the taper be slightly shorter by about 10/1000ths of the depth of the plate, which is about 1/4 of an inch, it looks like. So then I could ring the bolt head and a washer down snug, which would tend to pull this stud in tight. I have an arc welder, of course, a dial arc, and I could weld a stud in, but the big trick is, how do you get the stud to be perfectly square? You guys, some of you guys probably know the trick, but I don't know what the trick is, and I'm not inclined to find out. So, another thing I could do is make another shaft, or either use this shaft and take a bigger, I have some 3/4 inch plate. I could I could weld some 3/4 inch plate to this deal here, okay? And then take it and face off the back in the lathe, and then chuck the newly faced off and square back to the lathe, and then turn this entire front face. It seems kind of labor intensive, and You know, probably not the correct way to do it. Alternately, I could have a Morse taper here, and I could have this thing extend. I could cut the matching taper on the stud. I could have this thing extend and have a, instead of tapping this thing out, I could have it extend and cut threads on it. Then I could just screw a nut on this side. All this in mind. Keep in mind that the welder, of course, has a flat panel. I'd have to cut a. I was also thinking of adding a boss onto the back, like a piece of 1.25 inch, 1.5 diameter, cold rolled. I was going to weld it around the circumference here, and maybe you know, a half, 3/4 inch, or 1 inch tall. It doesn't really matter because inside that side of the welder there's nothing. There's some circuitry and some other stuff, but there's nothing of any critical importance in that area that couldn't easily enough be relocated right or left. So then I could have this thing. I could have this stud sticking into a really deep bore, which would probably be the ideal solution. Then I could weld the tip of the stud, which would be up about where my fingernail is. So what do you think? What's the solution here? I need to know. Inquiring minds need to know. Remember, this is from your famous dip-pak MIG welder series of, this is the continuous saga of ongoing repairs and modifications to my dip-pak 200 MIG welder, formerly made by the company formerly known as Airco. Remember, this is the plate. That's the top. That's the non-factory braze. This is the bent stud. Other than the guy making the movie, of course, another bent stud. But we can leave that out and talk about it later. But this has got some score marks in it. It's not really a wonderful thing. It's got a flat spot, easily enough to measure that with the dollar caliper across and determine the depth of the flat spot. I could even cut that in with a welding grinder and detail it out with some flat files. It's not even really a machine shop job. Although tapering the shaft down here, that could be a machine shop job. Or I could measure the shaft. I could bore that plate very slightly undersized, make this and put this thing in the freezer inside a bag of rice overnight, then heat the plate up on a stove, jerk the plate outside, take the bag of rice with the thing inside it, and then bang this thing down into the plate, preferably with my with my boss added back here, you know, my stanchion or whatever you call it, you know, to stand off the additional part, which would be about the height of where that middle of that first or second ridge is there. This thing would be bored out, right? Miller uses something called a fiber washer. As a matter of fact, they use a fiber washer both on the inside of the spool, this being the spool, and a smaller one on the outside of the spool. This particular welder, which is an Airco, doesn't use a fiber washer at all. Instead, it uses this black one. So what do you think? Give me an idea on this. I need to get this thing back together, you know, so I can obviously use it as a welder instead of like an ongoing repair project, you know, and like that. So, you know, if I need to replace these screws and the nuts, so that's not a big deal, you know. I got nothing but screws and nuts. I got, you know, dozens of pounds of the damn crap. So, you know, I don't mind modifying it, but I have to modify it for the better. And this thing has to be a good welder when it's done. And how it arrives at that location is not really of critical importance. But what is important is that the thing function and the drag be even as this thing turns. So when the welder's MIGging and it goes beep, 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 long beat, the brake has to work correctly in all positions, you know. Otherwise, I'm not going to get a good weld out of it. I know that. Okay. So get with me. Shoot me an email. I'm ready to hear your proposal. Thanks a real lot for watching today, and bye-bye now.